Okay, so let's do the helper number 2. Let me just move the screen right here. Oops, I shouldn't be doing this. Alright, so the very first question is what is the average mass of chlorine? I have 35 chlorine as a 76% and 37 chlorine is, I don't know this number. So there are two types of the chlorine, right? 35 and 37. So chlorine 35 and the chlorine 37, right? And one of them is 76%. What's the other percent right here? Well, there is only two types of isotope, right? So this probability has to add up to 100% here. So I can actually tell you that 37 chlorine is only 24%. So once you find out this number, that number, convert this to the fraction 0.76 and 0.24, and then let's just get average mass. So the average mass is equal to fraction of 1 times the mass 1 plus fraction 2 multiplied by mass 2. So let's just plug in the number here. That's going to be 0.76 multiplied by 35 plus 0.24 multiplied by 37. So if you calculate this number, now let me just try to calculate this one too. So Excel. Just give me a moment. I need to change the font size. Alright, so I believe it was 76 and 24. So let's just type in the whole thing. 0.76 multiplied by 35 plus 0.24 multiplied by 37. So that will be the average mass, 35.48. So 35.48 gram per mole. That's average. Alright, so let's do the question number 2. State the definition of molarity. So let me just erase everything. Maybe I should probably, no. Okay. Definition of molarity. It's simply a number of mole of solute in every 1 liter solution. So that's the definition here. So if the 2 liter of water contains 0.5 mole of Cl2 gas, I want to actually talk about this Cl2 here. Cl2 is actually this molecule right here. It contains 2 Cl atoms, another Cl atom, but it is a one thing right here. That's one thing. That's a one molecule. This is molecule. These are atoms. So let me just change the color right here. Those are atoms, okay? This whole thing is a molecule. Alright, so I clarify that. So let's just go back to the whatever the question that I was working on. So 2 liter of water contains 0.5 mole, right? So by the definition, right, we want to know how many mole of Cl2 is in 1 liter, right? So 0.5 is in 2 liter. Then to get the molarity, M is actually equal to 0.5 divided by 2, right? Because you have every 2 liter solution contains 0.5 mole, right? Mole per liter, right? So that will be 0.25 mole. Okay, so that's what we need to do for the question number 3. Alright, let's do the question number 4, sorry. The question number 4, we don't know the number of mole of Cl2, but we do actually know the mass of Cl2. That's good enough. So we have 50 grams of Cl2. But remember that we used to calculate this 35.48 gram per mole, right? So this one right here, let me just try to maximize the whole thing. Gram per mole of Cl, right? So if I want to know the Cl2 molecular weight, then all I have to do is multiply this number by 2, right? So if I want to know gram per mole of Cl2, right? That means that each one of those Cl weighs, each 1 mole of Cl weighs that much. The Cl2 weighs twice as much, right? Because you have 2 of those, right? So I'm going to multiply this number by 2. Multiply by 2. So that's the molecular weight of this Cl2 molecule right here. So each 1 mole of Cl2 weighs 70.96. But I only have 50 grams, right? So 50 grams divided by the molecular weight. So mass divided by molecular weight is going to give you number of mole. Number of mole, right? So I'm going to use this formula right here. So 50 grams divided by 70.96. That's the number of mole of Cl2. Of Cl2 in 2 liter solution. Right? Just put it somewhere around here. Right? Then, what was the definition of the molarity? Molarity is the number of mole of Cl2 in every 1 liter, right? 1 liter solution. Solution. Right? So 2 liter contains that many mole. Then 1 liter is going to be half of that, right? So this divided by 2. That's the definition of the mole, right? So what I did is number of mole divided by the volume. Let me just write out. So because definition of M is number of mole divided by liter, right? So I use these definitions. So number of mole divided by 2 liter, right? That's the mole right here. That was actually 0.35. Yep, 0.35. So that one was 0.35 molar. Alright, so we're done up to here. Okay, let's do the next question right here. So if the density is given here, then how many more of Cl2 atoms in 2 liter? This is not in the water, by the way. These two are separate problems, okay? This one is a pure Cl2 liquid or gas. I think it's a liquid here. So maybe a gas, but it's a condensed, really heavy gas. I would say probably it's a liquid. But anyway, 1 liter contains that much stuff, right? Only thing it matters to me is the mass here, because if I know the mass, and then all I have to do is divide by the molecular weight to get number of mole, right? So if I have the density, I need to get the mass here, right? So the density is mass divided by volume, right? So to get the mass, all I have to do is multiply this number and that number, right? So volume times density is equal to mass, right? So I'm gonna multiply volume times density here. So equal to times 573 is gonna give me the gram of Cl2. Okay, then what do I need to do from this point on? All I have to do is just divide this number by the molecular weight, right? Molecular weight is this one right here. So I am going to divide this number by 70.96, right? Then I get 16.15. So I have 16.15 mole of Cl2 in 2 liter of pure Cl. So that's the answer to question number 7. Alright, so then let's do the last problem right here. The last problem is another completely different problem. So we need to balance this equation right here. So to balance this equation, you can try it in your own way, but it's gonna give you a whole bunch of dead-end things. So try to follow my way of actually balancing the equations. You are going to balance out the rarest species first. Rarest. First. So these things has to be balanced one by one. So let's just count. Ca shows up once on the left hand side, right? And Ca shows up once on the right hand side. We don't care about these numbers, right? Right here. Whether it's gonna Ca is not in here or Ca is not in here, right? So Ca shows up once each for the left and right. Oxygen is gonna show up how many times? It shows up here, it shows up here, so it shows up twice on the left and then shows up twice on the right hand side. That is not rare. So Ca looks like the most rarest, right? So we're gonna balance Ca. So how many Ca do I have on the right hand side? I have 3 Ca on the right hand side, right? So what do I have to do here? I have to multiply the whole thing by 3 here, right? Then I have 3Ca on the left hand side, and then I have 3Ca on the right hand side. That's checks, right? Alright, the next up, what's the rarest species among the rest of the things that's not balanced? P, right? So we're going to balance P next. So this one right here, that one, contains 2 PO4 unit. Each unit contains 1 P, right? So I have 2P here. 2P and 8 oxygen here, right? So 2P on the right hand side in total, because the H2O doesn't contain P, right? Then how many of this guy do I have to balance the P? 2, right? Because there is only 1 P in this molecule right here. So I have to multiply the whole thing by 2. Okay. Next up is going to be either oxygen or hydrogen, whichever the one that you want. Because it's going to show up the same way twice in... Oh, maybe the hydrogen, right? Hydrogen is better. Hydrogen twice on the left and then 1 time on the right, right? So let's do the hydrogen. So P is balanced. So let me just write that the P is balanced. 2P and 2P, right? Next up is a hydrogen. The hydrogen, I have 6 here, right? I have every one of those CaOH2 contains 2 hydrogen, right? And I have 3 of those. So multiply 3 times 2 is going to be 6, right? And then the next molecule, H3PO4, contains 3 hydrogen, right? 3 hydrogen for each one of those, but I have 2 molecules, so I have 6. So 6 plus 6, I have 12 hydrogen on this side. Now, do I have H in here? There is no H, right? So all the H has to come from this guy right here. Then how many H2O do I have to have? 6, right? 6 times 2 makes it 12. So that's going to be 12. Alright, the last things to balance is oxygen. Let's just count the number of oxygen here. 3 times 2 is going to be 6, right? Let me just write that here. 3 times 2 is 6. And then 2 times 4 is 8. So total of 14 oxygen on the left hand side. And then the right hand side, I have 8 oxygen on this guy, and then 6 oxygen on this guy, right? So total of 14. So it checks. So all of these things are balanced. So the final answer is going to be 3 CaO2 plus 2 H3O4 becoming 1 Ca3PO4 2 plus 6 H2O. So that's how you balance the equation.